All right. So, log properties, right? Let's start with what we know. So, we know that if we have a log equation like 2 times natural log of x plus 1 equals 10, that we could isolate our log by dividing by 2. And we know this is base e, so we can say that e to the fifth equals x plus 1, and then we could say x equals e to the fifth minus 1. And if we plug that back in, we should get a positive number that's being natural logged, so we're all good, okay? But the concern with this whole what's new is that we have more than one log. And so we need a way to figure out how to get more than one log into a single log, okay? All right. So once upon a time, you learned about product properties for exponents, and you've probably learned about product properties for logs as well, okay? So let's do a little warm up. X to the 3 plus 2. What does that give you? X to the fifth, good, okay. And you might also see this as x to the 3 times x to the 2, right? If you have two different terms and they're multiplied together, what do you do when they have the same base? Well, you can add the exponent, right? So in general terms, we can write it like this: x to the m plus n equals x to the m times x to the n, right? When we have two exponents that are added, we can split them into two different terms. Now the flip of that is true. So, and x to the m times x to the n equals x to the m plus n. Okay. So I think that's fairly straightforward for us. Now it turns out that there is an equivalent property for logs. So if I said log of 3 plus log of 5, what do you think that's going to be equivalent to? I have one guess, log of 3 plus 5. Any other guesses? Log of 15. Okay, so let's do this. Pull up a calculator if you have it. Type in log 3 plus log 5, and then type in log 8 and log 15. See which one it equals. All right, I'll give you a moment to do that. All right, so when we type those in, I think we can see that log 3 plus log 5 does not equal log 8, so a very excellent guess, but it does in fact equal log 15, okay? What that means is that our product property for logs is log of m, log base b of m, plus log base b of n equals log base b of m times n. So we're turning that addition into multiplication when we condense them. Now it means that the other way is true as well, that log base b of m times n equals log base b of m plus log base b of n. Now, the reason why I wanted to show us the parallel property in exponents is because we see a lot of this same structure, that when we're adding, it becomes this like multiplication situation. And similarly, when we're adding, it turns into a multiplication situation. Okay. And that should kind of make sense logically, because we're thinking that exponents and logs are really two of the same form, right? They're the same thing. It's just one helps us find exponents and the other helps us find the number that we're trying to look for. All right, so let's do two quick examples here. All right. The common directions for log expressions, I either ask you to expand or I ask you to condense, okay? So in this case where I only have one log, I'm asking us to expand because I want us to write it where it's like something plus something plus something, okay? So I'm really asking us in this case to use this bottom line. And so if I apply my property, natural log of a times b times c becomes natural log of a plus natural log of b plus natural log of c. All right. So just using that property, straightforward, right? Only the multiplication. I might also ask you to not expand, but condense. Meaning if you have a lot of logs, and this is what we use for equation solving, I want us to condense it into one log, mostly for the purposes of equation solving. And for that, we refer back to the top one, okay? So if I condense this log, what do I get? Log D plus log F. Yeah, log df, log of df, okay? Now, real quick though, here's what it's not equal to. It's not equal to log d log f. Does that make sense? Like, we don't just get rid of the plus sign. We actually, it looks like factoring out a log, okay? So it's not equal to the thing in the red, but it is equal to what you all said in the chat, log of df, okay? Before we actually go much further, let's go back to this what's new piece. How can I apply that product property to condense the left-hand side of the equation? Okay, so let's see how Eric got what he got in the chat. So he wrote natural log of x squared minus x minus 3 equals 2. Where did that come from? Someone help me maybe fill in the blank there. Okay, so the question is where does he go? Yeah. Wait, what? That's okay. I do the same thing like a lot where I'm like, where did something even come from? Yeah, okay. Okay. So cool. So we've got this, which is kind of like our M. And we've got this, which is kind of like our N. So when we multiply that, we have x minus 2 times x plus 1 equals 2. And look at what we did right here. We condensed our logs, and now we have only one log, which looks exactly like all the equations we already know how to solve, okay? Which is pretty neat. So let's make sure we also change that last number, minus 2, okay? So this is how we're going to be using the log properties to help us solve the equation, all right? Okay, so let's go back down, let's keep going. So in addition to the quotient property, we also have, in addition to the product property, we also have a quotient property, okay? So the quotient property for exponents, and let's start with numbers, I could have x to the 5th, and I could say that's equal to x to the 7th over x squared, right? Because that tells me that I could do x to the 7 minus 2, which gets you back to 5. And in general, we can write that to be x to the m over x to the n equals x to the m minus n. But it could also work the other way, where we have x to the m minus n, and we want to split it up into a top and bottom part of our fraction, okay? Now, the same property holds true for logs. So if we use a numerical example, natural log of 20 over 2, okay? How do you suppose I could write that with more than one log? ln 20 minus ln 2. Good. So I could say ln of the top number minus ln of the bottom number. Okay. So we can type that into a calculator to confirm that log of 20 over 2 equals log 20 minus log 2. Okay. But the way we can frame that property is we can say log base b of m divided by n equals log base b of m minus log base b of n, okay? And again, the properties work both ways, so we could expand or we can condense, right? So 2 quick examples here. Directions for example 3 would probably be expand, because I've only got one log. Whereas the directions for 4 would probably be condensed because I've got more than one log, right? So when I expand number 3, I'm going to get natural log of A minus natural log of B, just like we said for the numbers, natural log of 20 minus natural log of 2. Okay. Now, when we condense example 4, we get log of D over F. Okay. All right, any questions about the quotient property? We've got one more property here, and Eric, this is, I think, the answer to your question. Okay. So thank you for your patience, but also thank you for asking the right question. All right. So we know that there's a power property for exponents. In fact, we saw this earlier where we had like something to a power and then raised to another power. In this case, we don't add the exponents, but we multiply them and we get x to the 6th, okay? That means we could summarize that by saying x to the m to the n equals x to the mn. Like I multiply the power, okay? Now for the log property, power property for logs rather, it works a little bit differently, okay? But it works like this. Log base 3, no, log of 3 to the 4, okay? I'll give you a moment to type that into your calculator, that power, so 3 to the 4, and then you're logging that thing, and you'll get a number. And then I want you to try this. I want you to try typing in 4 times log 3. And if you've put your parentheses in the right places, you should get that these two are equal to each other, okay? Now, earlier I said, oh, just take my word on this, like, you know, it's gonna be fine. But let's kind of go back to the power property or the product property for a moment. If I have log of 3 plus log of 3, if I condense my logs using the product property, I get log of 3 times 3, right? But if I just look at this left-hand side and I combine like terms, how many log 3s do I have? Yeah, I've got 2 of them. So 2 log 3. But check this out. If I have log 3 squared, the power property says I can take this power and I can bring it down to the front. And now my two sides are equal. 2 log 3 equals 2 log 3. Okay, so the power property is basically a shortcut for repeated addition. If you're adding the same thing over and over again, then it is a multiple of it. That's why we bring that power down to the front. Pretty cool, right? And so that means if we summarize this, that log of m to the power of n is equal to take the power, bring it down to the front, and we get n log m. Okay? A really handy property, you can move the power down, but you can also take a coefficient and move it up as a power. And so sometimes one form is going to be more useful than the other, okay? So if we apply that to example 5, this one, we can take that power. We can take that power, we can bring it down, and we'll get 5 natural log a. Right? Not a whole lot to that. What about if I bump the power up in example 6? Well, I could write that as log d to the 1/2. But I bet a question, especially from a textbook, is going to look like this. Log of the square root of d. Right, so there's that power of 1/2 is the same as the square root. Really useful to know how to go back and forth, okay? All right, any questions on the power property? We've got our product, we've got our quotient, we've got our power property. Okay. So here's the deal with the properties. Like on their own, they're really not so bad. And with equation solving, they're really not so bad. But sometimes you've got all of the properties in one question. And those are the ones where it's like, ooh, which one do I use first? Like, how do I know that I'm done condensing or done expanding? Okay. So let's go through a couple of these longer questions. And then I'll zoom back out so it's not too small for you to look at. Okay. But in this mixed practice section, let's look at the two cases. So if we need to condense a log, okay, so we've got a whole bunch of them and we want to make them into a single log, then this is a good order that I found really helpful. So if you want to condense a log, I like to look for the powers first. So if there are any coefficients, I move them up to a power. After I've done that, then I like to look for product. If there's any addition, I can turn it into multiplication. And then I look for any quotient, I look for any subtraction, and I turn that into division. Okay. So let's take a look at number 7 here. I think number 7 is a good example of one where I need to condense. And again, I know that because I have so many logs. Okay. Now on exams and such, I try and be more direct about the instructions. The only reason I didn't write instructions here is I want us to almost like learn how to predict. Like when a question looks like this, what are they probably asking me for? Because I think sometimes when we read the question, it's important to tie like what do those words mean with like what the equation or the expression actually looks like, okay? So let's do a quick scan. Any coefficients that I can move up to a power? Let's see, the first one has a coefficient of 1, the second one has a coefficient of 1. This third one has a coefficient of 2, so I'm going to bump that up as a power of 3. So I'll have log of x minus 2 plus log of x plus 5 minus log of 3 squared. Okay. That was my first step. I looked for any powers or any coefficients and I moved them up to the power. All right, next I'm going to look for any addition. When I see the addition, I can condense that into a single log by multiplying the two things that are being logged. So I scan through, I notice I can use my product property here, and that's going to give me log of x minus 2 times x plus 5, and then minus log of, you can write this as 3 squared or 9, it doesn't really matter. Okay. And then I look for any subtraction. And if it's subtraction, that means the thing that's being subtracted needs to go in the denominator. So log x minus 2 times x plus 5 over 9. All right. So some people, especially if you have had a lot of familiarity with logs, you can almost do this all in one step. But if you've always been like, I never really know what to use when or what order might be good, then it's not a bad idea to kind of follow this process, okay? Um, but does that make sense in terms of how we condense a log using the power, product, and quotient property? All right, let's take a look at expanding log expressions, okay? So when we're expanding log expressions, I usually do it in kind of a reverse order, but really I just move the power to the end, okay? So the first thing I look for is I look for any multiplication. And if I see that, I change that to addition. And then I look for any division, and I change that to subtraction. And then finally, I look for any powers and I bring them down. I bring the powers down to the front. Okay. So let's use that order: multiplication, division, and powers to talk about example 8. Right. So with example 8, I think we can kind of guess that these directions are to expand because there's only one log. Okay. So I could do this: natural log of x to the 5th plus natural log e to the 6th, right? I've taken any multiplication that I see on the top and I've changed it to addition. I've used the product property. Now we can almost do the same thing on the bottom, right? We've got natural log of y squared plus natural log of y z to the 7th. Okay. Um, wouldn't it have to be? Yes. Okay. So do you see how like y squared and z squared are multiplied together, but they're both in the denominator? That's why I put these parentheses around here. Okay. Because how should I connect this first part to the second part? Like, what property am I using? Yeah, it's subtraction. Okay. So we're going to put a subtraction sign in here. Now, some people like to write out this step. Okay. Some people like to jump right to this: natural log of x to the 5th plus natural log e to the 6th minus this one minus the second one. Okay. Some people like to go straight to that step because they're like, oh, in my brain, they're both on the bottom, so I know they're both minus. But where did that come from? They're both minus because you had to distribute that minus sign. Okay. So I'll make that first step kind of optional for you. You don't necessarily have to do it if you know that anything divided is going to be a minus sign in the front. Okay. Now, to the question about simplifying the numerator, there is one spot where we can simplify, right? And that is this right here. So natural log of e to the 6th, right? This becomes more clear when I use my power property. I'm going to bring all those powers down as coefficients. 5 natural log x plus 6 natural log e minus 2 natural, wow, 2 natural log y minus 7 natural log z. The reason why this one we can simplify is because log e, or natural log e, this part goes to 1. So really, I can say 5 natural log x plus 1 minus 2 natural log y minus 7 natural log 7 as my fully expanded answer. Or sorry, that should be a 6, not a 1. Okay, so Eric, to your question, wait, I think I missed a bunch of questions. That question was, for example, 7. Oh, okay. So Richard, for example number 7, you can FOIL it out, but one of the weird things that happens as we get sort of higher and higher in math is it's almost like don't do more work than you have to. So if you, like, the point of this problem is that I know you know how to multiply, like you know to multiply, not that you know how to multiply. So if you FOIL it out, that's fine, but it's actually just fine to leave it like x plus 2 times, x minus 2 times x plus 5, okay? Okay, Eric, why do we do the product before the quotient? Okay, so you could do the product before the quotient, or honestly, you can do both of those at the same time, okay? I kind of find it easier to think about them at the same time because when we think about like order of operations, pluses, multiplication and division sort of happen at the same time, right? So anything like these two are connected by multiplication, right? So I know I can do the product property there, but these two are also connected by multiplication, but together, and that's why I have the parentheses in pink, together they are divided by that. So that's why those collectively have a minus sign in front, okay? And then why does that become a 6? Okay, so as we move along, we're sort of adding on to a lot of the other things that we've learned already. So there were these homework questions where I was like, I want us to solve logs without using a calculator, and this is exactly that problem. So 6 natural log e is the same as 6 log base e of e. Log base e of e is 1, so 6 times 1 gives me 6. Okay? Yeah, exactly. Perfect. Great question, though. Really important thing to look for. All right. For the sake of time, I'd like us to choose one more problem from 9 through 12, okay? So take a look at 9 through 12. I'll see if I can squeeze them all on one page. And let's pick one that we're going to do together. I will fill out the other ones so you can take a look at them on the answer key, but let's pick one to do together right now. All right, I hear some, for example, 10. Anybody else have a preference? 10, nope. Okay, cool. We'll do number 10, and then I'll fill in the other ones before I upload the notes, okay? So for this one, all right. So one of the things that I like to do before I start to use my log properties is I like to write everything with the power so I can see the power, okay? Now on the bottom, I know this is y cubed. Okay, so at some point I'm thinking I'm gonna need to bring that 3 down as a coefficient, but not until the end. And then I also have z minus 2 to the, z minus 2 to the 7th. Right? So I know at some point that 7's probably going to have to come down to the front. And why would I put z and 2 in like the same problem when they might look like each other? So one of the things that I do to kind of help myself from mistaking the two, I put a little squiggle through my z so I know it's a z and not a 2, okay? But the question then is, how do we rewrite the top so it's x to some power, okay? So let's go back for a moment. If I have square root of x, that's x to the 1/2. And it's x to the 1/2 because it's x to the 1 inside here and 2 on the outside. And when we had the cube root of x, we said that was x to the 1/3. And we have a 1 on the inside and a 3 on the outside. So what do we think we could rewrite as the 6th root of x to the 5th? Okay. So I like that we know the 6 is going to be on the bottom, okay? Because I think we can see that this square is down here, this cube is down here, so this 6 must go down here. But this 1 became our numerator, and this 1 became our numerator. So in this case, our numerator shouldn't be 1, but it should be 5. Okay. Yeah. We could say x to the 1/6 to the 5th, and then once we multiply them, we'll get 5/6. Okay. All right. So that's sort of like a prep that I do for myself. I make sure that I can see all of the powers. And then I'm going to unpack them. And maybe it's best if we unpack addition and subtraction together. So log base 9 of x to the 5/6 minus log base 9 of y to the 3rd and minus log base 9 of z minus 2 to the 7th. Okay, so I just did that thing I was talking about in the last problem where I kind of skipped that step with the parentheses, the pink parentheses. I just knew that the y cubed was on the bottom, and I knew that the z minus 2 was on the bottom, so I just subtracted them both. The last thing we need to do to simplify is all those powers, whoops, wrong color, all these powers come down as coefficients. Okay, so 5/6 is going to be here, 3 is going to be here, 7 is going to be here. And that, my dears, is our answer. All right. Are there any questions about number 10 here? Okay. So I'm going to stop sharing my screen.